biological sciences at the Animal and Plant Health Agency in the UK. And Paul has a long history of risk analysis in sewage water and other environments for human pathogens, and has also shown a long interest in the factors that influence the emergence of new pests. And it is on that topic that he's going to present us with a talk. Paul, the floor is yours.
Thanks, Jan. And I'd like to start by thanking the organisers and EFSA for inviting me here today. It's a great privilege and an honour to be giving this. I'm going to be talking about drivers in action, and that's horizon scanning for the emergence of new viruses in animal and public health. Okay, so a quick overview of this talk. First of all, I'm going to define what I mean by horizon scanning, and then I'm going to go into complex scenarios and combination of events. I'm going to revisit the idea of spidergrams, which is something that we developed about 5 years ago now. I'm going to say a bit about identifying unknowns. You might have heard about known unknowns and all that. Then say a bit about the internet and approaches that other fields use, and give my closing thoughts. And if you don't get any other message from this talk, I believe that horizon scanning is all about getting the right experts together and talking. Okay, so horizon scanning for viruses, well, it's not just about identifying the next virus. It's building on the theme that Tony developed in his talk, and that is what are its roots and where's it from. So we've heard about Schmallenberg virus since November 2011, but before that it wasn't even in the textbooks. But that's the sort of thing we're trying to predict here, but maybe not give it a name, but just sort of predict what roots it might come from. And it's quite interesting because a paper came out a couple of years ago saying that they had been cases of abortion in livestock in South Africa in 2006. They looked for Rift Valley fever virus, they didn't find that, and they're suspecting it may have been Schmallenberg. So in horizon scanning terminology, that might have been a weak signal that was missed. Okay, so the problem that we face as horizon scanners is that we're up against a background of change. The world is changing and the virus is changing. I'm not going to go through all these drivers in details, but a really good example of how both the world and the virus changed is in the emergence of chikungunya in Italy. So that was an example of globalization and a mosquito coming in and establishing, and then the virus actually adapting to that mosquito. So the sort of horizon scanning I'm going to talk about isn't the present or short-term disease monitoring where you say, look at what's happening in France. So we've got blue tongue virus, serotype 8 in the middle of France, and try and speculate whether that's coming to the UK next year. I'm thinking much further ahead. I'm thinking in the future, in the medium to long term. So it's about understanding the drivers and the pathways, and in particular, it's about looking for combination of events and how the world is going to change in terms of giving these new routes, hosts, and interactions. And as I've said and hope to show, I think the internet is going to be a great source of information on what people are doing. For example, I can show you how you can look into their chat rooms and see what they're talking about. The prediction, though, is so difficult of these complex scenarios because they're so complex. So who would have thought that there was any relationship between use of an anti-inflammatory drug in cattle and increase in rabies cases in Italy? Well, the drug was used illegally in cattle, but it kills the vultures, and there were millions of these vultures in Italy, and they were reduced to the low thousands, perhaps even the hundreds. So we're talking a massive reduction in the vultures, which ate the cattle carcasses, which then piled up, which was great food supply for dogs. So feral dogs increased, and that meant there were more dog bites and more rabies cases. Another example I like is West Nile virus in swimming pools in California. So during the economic boom in 2005, 2006, a lot of houses were built with swimming pools. Then they were all repossessed in the crash. The swimming pools became stagnant and became mosquito breeding sites with an increase in the vector for West Nile virus. Now, when I hear or read about these, I think, well, why didn't I think of that before it happened? So I'm asking the question, how can we go about generating these complex scenarios before they happen? And one way is if you can find someone to tell you one. And I went to a Living with Environmental Change meeting in London. I think it must have been about 2009 or so. And I'd actually just been to the Antarctic. And I got talking to a Professor Alan Roger, who's at the British Antarctic Survey, and I explained my problem that I need to think up combination of events. And he said, oh, well, I can tell you one right now, and it involves the breeding seabirds on the island of South Georgia in the South Atlantic. So they all nest on the ground where they're vulnerable to rats. The rats were introduced by the whalers back in the 1800s. On top of that, we've got climate change, and these are the glaciers that are in retreat. So there's the Fortuna Glacier there. Most of the glaciers are now in retreat because of climate change. So all those ones in blue are retreating, and there's the odd one or two in red that's actually increasing. But anyway, the thing about rats, they're introduced here in the whaling sites, and the glacier was here in the sort of 1950s, and then it's retreating in the 1970s. And so the thing about rats is they don't like walking over ice. And as soon as the glacier starts to expose some land here, then they can get round across that bit and into the rat-free zones where the seabirds are breeding. So it's a great combination of events. And on top of that, if I say that these birds, although they're not particularly threatened at the moment, there was a great photograph in a competition of one of these birds, and they're about 6 foot wingspan. They're actually vultures of the Southern Oceans, and it had a brick red head because it had been acting like a vulture and eating a carcass of leopard seal. So if you get rid of all these birds, is that similar to getting rid of the vultures in Italy? So would we start seeing elephant seal carcasses pile up on these bays in South Georgia? Anyway, if you haven't got a friendly professor to tell you some of these combinations, you have to start thinking about how you're going to work them out for yourself. So what I did was I started categorizing all the drivers I could think of into different groups. I had zoological, farming practice and husbandry, sustainability, environmental and climatic, land use, ecological and socio-economic, anthropogenic. And I started filling in all the drivers I could think of. Then I had the idea of randomly generating complex scenarios just by pulling out one from one category, combining it with another from another category. So I guess most probably will be meaningless, and here's one here. Increase in wind turbines give a change in livestock breeds, gives an increase in feral dogs. I can't really see one there, but some might give insights, and I know I have forced this one by putting it in, is the vulture example that I've just described, but you can see how it might come about. So we start off with an anthropogenic one, that's the diclofenac. Gives a collapse in a scavenger species, that's the vulture from the zoological driver category. Gives a pile-up of cattle carcasses, that's in the farming practice one, I would argue. Gives an increase in feral dogs. And so you can start putting that together in, this is the start of the formation of a spidergram, as we coined the term. And then, more importantly, you can start building in branches and extensions. So if you're getting cattle carcasses piling up, you're going to have other things happening, not just increase in dogs, but you might get pressure on landfill sites, you might get more seagulls, more rodents, increase in insects. So you can put them in as your branches and extensions. And one thing I'm really keen on is combinations of events. And following on from the glacier one in South Georgia, I always like looking at environmental and climatic. So I would build in here flooding and warmer temperature. So when you get flooding, you can get power supplies failing because the power plants are flooded. You get mixing of sheep and cattle, which can give diseases like malignant catarrhal fever. You get increase in rodents and snail vectors for fasciculiosis, increase in insects. So there's a whole load of other combinations you can build in, and then you can start hanging your viruses on these pathways. So anyway, we had this European Science Foundation funded workshop back in July 2010, at which Stefano Pongolinghi gave a very nice talk on chikungunya virus, and all the participants were very positive, and we found that the spidergram approach provided a framework for how different factors could interact irrespective of the virus. So this actually enables the testings of combinations which we wouldn't previously have considered, but which would ultimately be tested in nature. And the key thing is that these spidergrams generate discussion points and new angles to get people talking. And a sidekick sort of spin-off was the use of spidergrams for developing case control questionnaires, as in the case of hantavirus. I'm not going to go into that. But I will say a bit about the Nipah virus spidergram that we developed, and Bill's already mentioned Nipah virus this morning, and I was really interested to see that he'd got some predictions for the impact of climate change, because that's exactly what we looked at. We looked at the effect of temperature. So it's a fruit bat-borne virus, and pigs are exposed when you get deforestation, so they have partially eaten fruit dropped by the bats, which is contaminated with their saliva. So it's all about level of containment of the pigs. They get infected, then they infected some humans, and we developed this spidergram to look at how temperature could affect Nipah virus emergence through a range of seemingly unrelated factors, including migration, deforestation, and war. So essentially, we were looking for the impact of climate change on Nipah virus. And this was the spidergram they came up with. More importantly, the people in that particular group then put together a 2x2 this sort of table where they could pairwise compare each link. So this is the one that's being affected. So I've got migration, level of containment, temperature, war, host behavior, that's actually human behavior, poverty and deforestation, and these are the effectors. So if it's a plus, then this one is affecting that one. So you can see that temperature actually affects them all, but level of containment and host behavior is affected by all of them, and as all of them are affected by temperature, you could sort of make the jump that the important ones, level of containment and poverty, are affected through multiple ways by temperature. But some of these links are actually not that obvious. So if you pull out something from the, say, acid rain from the environmental and climatic driver category, and then a zoological one, wild bird behavior, well, I'm a bird watcher in my spare time, but I have no idea how acid rain could affect bird behavior, let alone what outcomes could result from that. But if I fill in the missing link, that is that acid rain actually dissolves out calcium, so you get a decline in snails, which the birds rely on for calcium to have their eggs, then it starts to make sense, because the change in wild bird behavior is calcium foraging. Now, I'm not saying that they go raiding the tops of milks like they used to, bottles of milk like they used to in the UK, and that was considered to be a Campylobacter or Salmonella risk. They're not looking for calcium there, they want the cream of the milk because it's high in energy. But what this chemistry, a physical chemistry book that I was reading, where it actually gave me this scenario, said was that in the Netherlands, the wild birds were actually raiding the chicken houses to get the eggshells. That's important if you're trying to look for bridging species that may transmit, say, avian influenza H5N1 virus from, say, waterfowl, which have migrated from, I don't know, Western Siberia, maybe carrying the virus. So you're looking for a bridging species that takes the virus from those birds and into the chicken pens. So I want to get on now to the known unknowns, and as Nigel Walker said, these are difficult to get your head around. I'll have a go at explaining what I mean by these. Well, known knowns is that's just we know what we know. We always feel very safe in this box, but as a horizon scanner, we need to break out of this box. And a good way actually is to ask a stupid question, so never be scared of asking stupid questions. We then move on to the known unknowns. Well, that's just another way of saying the data gaps, and we've been dealing with those for years as scientists. We always like to say further work is required in any report we write. Well, that's just the known unknowns. A good one is the Ebola virus levels in dogs which had been exposed to Ebola virus, if you were doing that sort of risk assessment. We then move on to the unknown knowns. Now, I would argue that acid rain example affecting wild bird behavior is a good example of an unknown known, because it was known that acid rain affects calcium. It was in my physical chemistry book, but I didn't know about it, and I'm a risk assessor who does risk assessments for H5N1 getting into chickens, and I should know about that. So I need to think out the veterinary microbiology box. And then lastly, the unknown unknowns, and these are probably the most difficult. And at APHA, we've had several members of staff, many virologists, going over to Liberia to help out there, and one of them came back. Her name's Emma Wise, and she said the thing is, when someone dies, all the relatives are notified by mobile phone very quickly. So, and with the good transport out there, the flights and everything, they can be there next day for the funeral where they get infected. Before this combination of mobile phones and better transport, they would have not got to the funeral till afterwards. So I think that was an unknown unknown. And I think an unknown unknown is really the outcome of a change in a world combination of events. And this is where I think spidergrams can actually help. And of course, once you've identified an unknown unknown, it very quickly becomes a known known. So it's a sort of reiterative, cyclical type process. Now moving on to using the internet, and I really like this example. It's about, again, bird flu, H5N1 transmission through frozen duck meat to backyard chickens. So those are the backyard chickens, and these are the ducks. Now, these ducks, although they're infected, they don't really show symptoms with bird flu. So they can be infected but infectious, but you don't really know. Maybe the farmer suspected they were a bit off colour and thought, I better take them down the slaughterhouse, where the meat ended up in the frozen meat department of a supermarket. And then it was fed to backyard chickens, which were, well, the problem with chickens, as soon as they get a whiff of this virus, they're dead. So you can pick it up very quickly. The point is that they'd actually worked out the risk of this getting into the food chain was very low, and from a human point of view, the risks are incredibly low. But to these chickens, no one had really thought about the fact that that duck meat, raw duck meat, was going to be fed to their backyard poultry. But if you actually look on the internet chat rooms on feeding meat to poultry, there's one here I found in 2009, can chickens eat meat or not? And there's a lot of people, they all acknowledge you're not really meant to do it. In fact, it's against the law. But they say, my chickens get all food scraps. I would only give them unprocessed meat. Mine get meat, but nothing too greasy. This is another example of an unknown known in the fact that it was known, but we as risk assessors didn't actually know it. Now, looking at a slightly different approach where we overlay a new scenario on a known pathway. So I've just taken this as an example, really. So this is Kuru in Papua New Guinea in the Fore tribe. And I think it was Carlton Gajuzak who worked out that it's because of the tradition of mortuary cannibalism, where I think it's the women eat the brains of deceased relatives. And this transmits this TSE called Kuru. So in terms of the new scenario, well, I thought I'd change humans to cattle, and the disease then is BSE. But of course, we're not actually feeding neat brain to these cows because we're rendering them. It's meat and bone meal. It's a farming practice type thing. But the thing about rendering, of course, is that it might inactivate some of the TSE agent, but maybe not all of it. And more to the point, different TSE strains differ in the thermostability. So maybe now we're looking for a virus with a particular combination of properties to fit this new scenario. And I would argue that perhaps we selected for a more thermostable TSE strain, that's BSE, and add on the fact that it was or is incredibly infectious to cows through the oral route. I think a milligram of cow's brain could be the oral ID50 for a cow. So I've often thought, because I did quite a lot of BSE risk assessment in the 1990s for the UK water industry, and I've often thought about the origin of this disease, and in going back to this horizon scanning and experts talking to each other, I thought, well, if I got a room, or if we had a room full of all these experts, so someone who knew about rendering and the thermal conditions of generation of meat and bone meal, somebody who knew about the thermostabilities of TSEs, an epidemiologist who knew about Kuru and the oral routes of transmission of Kuru through eating brains, and someone who also knew about cattle feed production and recycling of cattle brains to MBM. We got that group together. Would they have said this is not a good idea? I suspect they perhaps wouldn't have twigged, because they might not have realised that you could select for this very thermostable TSE strain. I don't think anybody could really think that just a milligram of cow's brain would be enough to infect half of the cows that dose was given to. And also, if they had spotted it, no one would have known they'd actually done it, because as Fiona Litcridge said, if you've done your job properly as a horizon scanner, nobody knows you've done it. So really, I think as horizon scanners, we need some help in terms of what I call trying to make some sense out of nonsense. And I've looked at what other fields do, and I was vaguely amused by this thing in 2011 where they're trying to get virtual monkeys to recreate the works of Shakespeare. Now, that's not really going to help us, because you're not going to know if you've got the right version or not. It is a case of making the sense out of the nonsense from those spidergrams. But I was encouraged by an online game that some molecular biologists were using to try and come up with a new structure for the AIDS virus protein, and they couldn't think it up, but the online community did. They're very, if you're drawing from the online community, you've got a huge source of cleverness and ideas to draw from. So I'm asking the question, can we think up an online game to generate complex scenarios? So my closing thoughts, this horizon scanning is all about trying to make sense out of nonsense and order out of disorder, in fact. But we do need just the right combination of people from a broad combination of disciplines. It's about keeping the experts in different fields talking, and you need a critical mass of scientists. Now, I believe these spidergrams give a good starting point in producing random links, and it's really important to come up with these combination of events. I've seen that in the talks from the previous speakers this morning. How you fill in missing information, I'm not quite sure, like that example of the effect of acid rain on calcium and bird calcium foraging. But the internet's a huge database, and the answer's out there somewhere. I think I've heard that before on television. So you can do things like text mining, and as I say, I'm wondering if we can set up some sort of web forum with a universal set of factors for spidergram generation. So can you think up an online game to generate complex scenarios? And I just point out we've actually published this work back in 2013 in Transboundary and Emerging Diseases. So thank you.
Thank you very much, Paul, for this very interesting presentation of a systematic approach to identify potentially meaningful developments that could lead to an emerging disease. We started a bit later after the coffee break than planned, so I think there may be one question for elucidation, if there's any. Yeah, over there, please.
Paul, interesting. Thanks very much. You've put forward a way of identifying links. Do you think you have to identify the strength of those links as well, i.e. put numbers on them?
Yes, absolutely. Yeah, that is probably moving into a quantitative type risk assessment almost, and it's getting the data. But if it's a really strong link, it's probably known, unless it hasn't been invented yet or someone's not thought of it. So if it's an unknown known, say, there might be data on it out there. But yeah, I think that's a really good point, William. Yeah, thanks.
Okay, thank you. Thank you very much, Paul.